Hi everyone. Hope everyone's being safe out there. My name is Nitish. We'll be joined by Preethi and Xiaoqin later in the talk, and we are here to talk about Airflow and how we use Airflow in our ecosystem, and how we mold Airflow to be used as a shield as a service, and what we mean by a shield as a service. So we'll be covering all of that as part of the talk. We are from EA Digital Platform, Data and AI. We'll delve deeper into that as well. So, a little bit about me. Uh, my name is Nitish. I'm a software engineer at EA. I joined around a year back. Um, Before that, I was doing my master's in Rochester Institute of Technology. And before that, I worked for Microsoft, where I mostly worked on Azure. And at EA, I'm part of the data platform team. So, we are Electronic Arts. I hope most of you know Electronic Arts. We are a large games team. We primarily delve into game development and publish games. So that's our main thing, games. And I hope you've heard of it. We have a large portfolio of games which we'll also get into. And our motto is we exist to inspire the world to play. So this is what drives us on a day-to-day basis, and I know it's a little cheesy, but it's fun to think about it. We have a large player base across the world. We have so many games and a large number of people playing our games every day. Games like FIFA, Madden, Sims, we see such high frequency of logins every day, people playing. And because we have such large player base, it means that we have a large quantity of data, lots of data. And this presents us with an opportunity to actually analyze this data set and improve ourselves every day with each iteration of game, and improve the gameplay experience as we see. And I think it's a huge and exciting perspective. So, little bit about the games we have. We have a wide variety of games, and this is only increasing every year. And the various challenges they represent, and the kind of games we make. It's been a prolific year for us, and you can see that we have Plants vs Zombies, kids games, Star Wars, Need for Speed, racing games, Anthem, and definitely you must have heard of FIFA, Madden, Sims. Uh, just to showcase that we have a large number of games under EA's umbrella. And the reason we have so many games is because we have so many studios under EA's umbrella. They're spread across the world. We have studios in Canada, China, India, Sweden. I mean, DICE is in Stockholm. So, and each studio has slightly different needs in terms of data, and different needs in terms of how they process the data, the pipeline of the data. It's just a huge variety. For example, live service games such as FIFA and Apex Legends would have such high volume and high frequency of data coming in, while single player games like Dragon Age or Mass Effect or even Star Wars, would have very limited telemetry in that regard. So as you can see that we have such wide variety. We even have mobile games, and it presents a separate and interesting challenge. So let me talk about who we are. So, EA Digital Platform is a central team within EA. We are here to cater to the multiple game studios which are present across the world. EA Digital Platform also consists team like commerce and identity, gameplay services, security and stuff like that. And it's a wide variety of services we provide to the multiple game studios. We are part of data and AI within this ecosystem. We manage the data pipelines and the various data sets. We also have AI applications and AI platform, which enables other teams to take advantage of. We also have a player network framework. It's an inbuilt framework which is devised in collaboration with multiple studios. It's it's a definition of how we send events and data to our data sets through our pipeline. It's a well-defined framework. This enables different departments and different studios to feed into the network and the data set and perform complex analysis on top of it. Machine learning, reports, dashboards, as you see fit. We have such a wide variety of use cases, and some structure is required to enable these use cases. So we have within data and AI, we have the central data platform team. We also have a data pipeline team, which consists of ETL engineers and developers who manage and deploy the data pipelines itself. But we manage the data platform. We manage how the data is accessed, queried within EA, as well as who accesses the data. So it's an important point. We also support multiple game studios. They have engineers, data scientists, ML engineers who are embedded within the game studios, so that they can tap into the data set we have and manage to build pipelines, their own analysis on top of the platform which we have. So, talking about the platform, we have to talk about scale. Uh, The data set in totality is in petabytes. It's a large number, it's a huge data set, and it's increasing almost every day. We have tens of terabytes of data generated every day because of the huge number of games which are being played across the world, and it's the volume is pretty high. We also have thousands of ETL jobs. This actually translates to almost hundreds of thousands to almost a million of job executions every day, because we have so many hourly and sub-hourly jobs as well, which run at such a high frequency. So, and we also have such untapped ETL jobs across the game studios as well, which are around 38 game studios. So if you take that into account, and the fact that we are trying to centralize a lot of the ETL pipeline, you can see that number shooting up to almost tens of thousands of ETL jobs, and a much more increased level of complexity. So as can be seen here, we're managing a lot of internal and external jobs. We need to focus on what's important here, providing a good platform and a noise-free setting for the platform to thrive on, so that it's easier for studios and teams across to use it. So I want to give an overall picture of the architecture we have, and the systems we have. So as you can see here, we have some legacy ETL jobs, ETL pipelines. They're still running. They still generate the most amount of data we have, but we are trying to migrate to the newer data platform. The legacy ETL jobs are deployed in a Hadoop cluster. They consist of Hive jobs, MapReduce jobs, and they're usually scheduled by Uzi. There are also other external ETLs which also feed into the dataset. This dataset represents the totality of the dataset we have, and they also feed into it through other external systems. We have legacy external systems for other studios and teams. And soon we want to move to the Presto platform. It's current major next gen, or the current gen, as you can see it. It consists of multiple clusters or dedicated resource pools. Each cluster would map to a certain department or team within EA. For example, we would have a dedicated resource pool for FIFA or Apex Legends, or something like that. Um, and even we can scale up and down the cluster based on the team's requirements, because of the volume and the type of pipelines which are required. So, and we also have a generic ad hoc cluster which allows other teams to run ad hoc queries and run ad hoc jobs on the cluster as well, which is a large ad hoc cluster we have. What we do is we allow people to interface with the Presto platform using API or JDBC. It is routed through a gateway. The gateway consists of multiple rules. The rule engine, basically, your query is routed to the corresponding cluster based on based on certain rules. So, for example, if you're from the FIFA team and you're shooting a query to the Presto platform, you're automatically routed to your dedicated resource pool, and the gateway manages all of that. We do have Airflow system which is running. All the new ETL jobs are being deployed into the Airflow here. We also trying to migrate some of the older ETL jobs there. It interfaces with the REST API. Again, the queries and the jobs are routed to their dedicated cluster based on uh, based on the job's metadata itself. So we have other complex rules going on. Again, we allow ETL ad hoc queries and other external ETL use cases if required through JDBC and again REST API. It's a pretty flexible platform, and that's how we see on improving it as well. So, having set the stage, I just want to give an overall picture of the problem we are trying to solve. We have so many game studios with embedded analyst teams and engineers, multiple data pipelines which we need to consolidate, and also external pipelines which we are trying to consolidate. Thousands of ETL jobs and almost 50,000 ad hoc queries every day using our platform. Again, we only see this number increasing with the amount of games being released and the amount of complexity which we see in the next gen of console actually. Um, and we have highly sensitive data sets, which this is something which I didn't touch upon before. Uh, we have sensitive data set in the sense that we have revenue information, active users, transactions, and these are highly sensitive data sets, and we would like to isolate the data set itself so that you ensure the person who should have access to the data only they get to access the data. um, we also have varied SLA requirements. We need to address varied SLAs during game launch season, especially that are staggered throughout the financial year. Especially, for example, FIFA 20 released this year, so the ETLs would have the SLAs for those ETLs would be much more higher priority than FIFA 19 or 18. So the motivation here is that we need a structured and secure way to schedule our jobs, as well as allow new teams to onboard to the new system and easily migrate older jobs. So adoption is important, ease of use is important, and because of the complexity of the data pipelines we have. So I want to talk about what was there before Airflow, how we grew. So we used to use standalone scripts and Uzi scheduler to schedule our jobs on the Hadoop cluster. We had an in-house CI/CD deployment tool. Basically, continuous integration and deployment was done through in-house tool, which we used to develop. We have the monitoring and auth models and a lot of standalone systems which were a little fragmented, but um, since the data sets grew and everything grew, we needed to consolidate and move towards a much more structured way of doing it. So uh, with that being said, we move towards having a central Airflow system instance, a common plugin ecosystem, so that people can just reuse the code base, codes which would interface with the Presto platform or interface with the data sets, so that the ETL engineers can just focus on what's important. Obviously, is monitoring and CI/CD. We also have a SSO integrated across EA, so it is important that our Airflow system integrates with that SSO and also allow multi-tenancy within that Airflow. So in the future, because of the amount of jobs we see, we would think of multiple Airflow schedulers and a self-serve orchestration system, which would allow the teams to spin up their own cluster when they see fit, and also improving workload management within those clusters. So, what we mean by Schedule as a Service and what are the objectives within the context of EA and EA Digital Platform? Um, it is important that we have multi-tenancy with RBAC. Each team should have an isolated view of their bags. This should be seamless. So when a user goes to the Airflow UI, they should only see their DAGs and not anyone else's. Especially since we have sensitive business logic and data sets within those DAGs. Uh, so it is important that we have multi-tenancy within the Airflow system. Ease of job deployment, this goes without saying. This increases the adoption across. This allows easy deployment. Also, it's one less thing for the ETL developers to worry about since they already have a heavy workload. In the same vein, it's ease of interfacing with the dataset is important. That's where the plugins come in. We have plugins which interface with our Presto platform, and all the engineers have to worry about is writing the pipeline logic and the queries and just filling parameters so that they can worry about just that, and the interfacing with the dataset is taken care of. Uh, Similarly, no service is complete without monitoring and alerts. The end user should be able to see when the job fails or if there is any problem with the Airflow instance itself, and also the ability to monitor continuously the jobs and the SLAs, especially especially during launch season or something like that. So, having said that, I would like to now pass over to Preeti, who will, talk about multi-tenancy and job deployment. So, Preeti, uh,
Thank
on.
you, Nitish. I'm Preethi. I'm part of the data platform team at EA. I've been with EA close to 3 years now. I predominantly work on an ad hoc query platform that leverages Hadoop Hive, today Presto SQL, Presto Gateway, as well as Airflow. Um, so, jumping into what Nitish mentioned earlier. So the first main pillar when it comes to scheduler as a service is multi-tenancy and RBAC. Why is multi-tenancy so important in our use case? As Nitish mentioned earlier, our teams are fragmented. There are different game studios which have different varied requirements. So multi-tenancy helps different teams utilize a single Airflow infrastructure while being guaranteed an isolated execution environment. At EA, this is limited to the web server. This is limited to the CI/CD process. This is also limited to the RBAC service. In the future, we would also like to extend multi-tenancy to both the schedulers and the workers. Every team has their own Git repo. Whenever the data engineers and scientists are ready, they check in their code. This code is automatically deployed to S3. Using an S3 Sidecar container, we have the ability to get the DAGs as well as the plugins deployed on the Airflow infrastructure. So, uh, what is the advantage of this model? So basically, every team is responsible for their own DAGs, and they're also responsible for testing their own DAGs. We just provide the initial repository and with some initial CI process. Any secrets associated with that particular team is a GitLab secret. So this ensures that the team is only concerned about their DAGs and no one else's DAGs. In addition to this, with multi-tenancy, as Nitish mentioned, there are certain smaller teams that may have smaller requirements in terms of Airflow infrastructure, while say FIFA and Apex may have a much larger requirement. We can have two or three smaller teams share one Airflow infrastructure. So this, of course, leads to limited wastage in terms of resources. So let's jump into RBAC as a service. Within EA, these multiple teams that utilize our data platform are referred to as self-serve teams. Every self-serve teams have different roles associated with different individuals on the team. For example, there are the individual developers, there is the team administrator, and then there is the self-serve account or the admin account. So they all three of them have different permissions that are associated with them too. For example, individual developers can only read DAGs of their own team. Team administrators, on the other hand, can rerun a DAG, for example, and they can also read the DAGs and basically see what is the new DAG that has been deployed, and also look into SLAs and other metrics. But your self-serve account is, in other words, the owner of the tag. It has read permission, write permission, and execution permission. So all the tags that are deployed by a certain team have are run using the same owner name. So this simplifies our RBAC as a service model. Uh, Having said that, let's jump into how we implement RBAC as a service. So with RBAC as a service, every team's associated roles are mapped to the native roles that Airflow already provides. What does this really mean? Basically, Airflow provides multiple native roles, as you're aware: admin, viewer, public, and so on. And as I mentioned earlier, every team has their own internal roles. They have individual developers, they have team administrators. Administrators may not just be one person; it may be multiple people within the team, and also they have the self-serve account. So we need a way to map that with the internal RBAC that is already provided with Airflow. Also, these teams have a standalone RBAC system where they ensure this information is stored, where they associate different usernames with administrator or developer and so on. So basically, we use a reverse proxy that is in between the user as well as the web scheduler, the web server. So your Nginx obtains the user information from the browser cookie, passes this information to the web server. The web server unwraps this to figure out who the user is, what is the permission associated with this user, and then maps this to native Airflow roles. So you may have a one-to-one mapping, or you may have a one-to-many mapping. So in other words, here we are basically using a custom security plugin. I leverage the remote user Fabot model, and this also helps with users not having to enter their username and password every time they log into Airflow. Uh, while we were able to achieve RBAC as a service and multi-tenancy as a service, an important pillar when it comes to delivering a scheduler as a service is job deployment. Data engineers and data scientists do not want to be concerned with the hassle of having to develop their DAGs as well as deal with the overhead involved in having to deploy these DAGs onto a production ecosystem. So enter Autodevops as a service. With Autodevops as a service, every team has their own Git repo. So all the team members start working on their code and on their DAGs. Whenever ready, they would check in this code. This automatically triggers our own set of integration tests. The team is also allowed to have their own CI testing modules integrated with their Git repo if they want to. And whenever this merge request is complete, we have the DAGs deployed to S3. We leverage an S3 sidecar container that runs on the Airflow pods that pretty much pulls the DAGs from S3 and deploys them on the various pods. So this similar model is used even for plugins. We basically check in, goes to S3, and the S3 sidecar container pulls the same. As you can see, the S3 sidecar container is one of the critical components when it comes to achieving auto DevOps as a service. So let me jump into what an S3 sidecar container really does. So we need a way to sync DAGs from multiple repositories uh, to multiple pods within the Airflow infrastructure. So the sidecar container runs alongside the web servers, the scheduler, and the workers. So whenever the DAG files and plugins are pushed to S3, the sidecar containers pulls them from S3 periodically. So what this basically does is it decouples the DAGs from the container itself and allows a sense of flexibility. Multiple teams can share the same cluster as each team's Git repo basically contains their own code, and from their Git repo the code is deployed to S3. And also the S3 location has tight access control. Only the CI/CD process within a Git repo can push the DAG to S3. So you may be wondering what we do in case of namespace collision. So we just associate a prefix in front of all the DAG names. Prefix is generally an abbreviation of the game studio name. For example, FIFA. Uh, Having said that, you may also be wondering how does a developer ensure that they have all these services when they are running Airflow locally? We provide a custom sandbox environment. By this, I mean uh, a custom Docker image, which is integrated with all the central plugins, which is integrated with RPAC, which is integrated with access to our data warehousing system. So basically, data engineers and scientists have the same environment locally as they would expect when the DAG runs in production. Having said that, this is the CI environment or a test environment, and they're not actually getting production access through their local setup. Whenever the DAG is ready in their local environment, they would go ahead and check in their DAG into GitLab, and you will have the CI/CD process which will kick off and ensure that the DAG is deployed to S3. Yeah. So having said that, I would like to invite Xiaoqin. Xiaoqin would be talking about the other pillars when it comes to achieving scheduler as a service. Thank you.
Thank you, Preethi. So, hey, a little bit about myself. So, my name is Xiaoqin. I'm a software engineer at EADB and AI, EADB Data and AI. I've been at EA for over 2 years now. Our team is actually one of the team that heavily leverage the Airflow framework for our data pipelines, and we're actually currently looking at how we can enhance the development process and other aspects as well. So let's go back to continue with the what we had for the schedule and servers. So one of the component is that we have custom plugins for easy of accessing the data sets. So as Nitish has mentioned, we have a common plugins repository so that our users can reuse the code. They don't have to worry about that, and they can just focus more on the developing the pipelines. So all of our common plugins are managed through a single repository, and we also have a very through wiki page to for our all of our available custom plugins for our end users, so they can easily identify what is available for them and what is something that they need to enhance or develop. They can request, and anyone can contribute to the plugin repository. And we also have a team which overlook the plugin ecosystem to make sure that the stand. Oh, my page is not. Oh, sorry, my bad. Sorry about that. Just to continue that, we have a plugin managed through a single repository, and anyone can contribute to the plugin repository. And the plugin and we have a team to overlook the plugin ecosystem to make sure the standards are followed. For example, that we want to make sure the plugins are reusable, and we discourage one-time use plugins. So in order to contribute, all the contribution requires merge request uh, and approvals. Once the plugins are approved and merged, they are deployed through CI/CD pipeline, and where the plugins are pushed to S3 bucket, and then the S3 sidecar syncs the plugins with each Airflow, with each Airflow pod. And we also ensure that we directly import the plugin instead of using the airflow.operator.plugin name to avoid import issues. And we have customized plugins and the wrapper to connect to our data warehouse so that users don't have to worry about the interfacing with datasets. For example, we have in-house plugins interface with our personal platform where user can submit queries, check partition availabilities, and any other requirements that make it easy to build complex stacks with our framework. And along with that, we also have ACL for our custom plugins. This is each team usually have well-defined workload, which allowed us to set up plugin SEL. And also, since we have a shared cluster, we thought it would be prudent to control the kind of workload in the cluster. So the SEL is set up by define the plugin access per team in JSON config, and then enforced through the GitLab CI test. And for all the new approved plugins, they are also added to the config. And so, for example, on the left you can see that in the policy definition we have defined a list of operators for the team. For example, ETL team, we have defined a list of operators that's available for them. And in the future, we plan if we are moving to a multi-cluster environment, we are actually plan to move to a more of a denial list for to show that for each team what are the operators that they can use. Okay. Now that we have take a look at our custom plugins, let's also take a look at how we are monitoring and alerting with our Airflow framework. We are having alerting as the servers so that user don't have to worry about like setting up monitoring alerting, so they can get notified if there's any job failure or systems down. And for example, we have Kubernetes provides a base level of fault tolerance, which help us to monitor that our system is running. And we also have pod level metrics and alerts available with Prometheus. And we also have Airflow service level metrics and alerts, as well as job level monitoring, which help our users to manage their jobs. And also we have email-based notifications and ELB alerts and monitoring. We have Prometheus and Alert Manager integrated as well. And we have the DAG level monitoring rules are set up within the Alert Manager, which allow us to monitor active tasks at any given point. And the system level alerts are also set up cluster-wide so that we can ensure that our Airflow cluster is running healthy. And this is an example of our monitoring dashboard, which we have integrated Grafana dashboard, which each team can see the tasks and DAX that's running currently. We're also monitoring the Redis and Postgres pod so that we can see the number of active connections. And since we have a shared cluster, so you can see that this shows the active running tasks and also the number of the task instance that's currently running, as well as the number of connection that's currently active. And this is another monitoring dashboard that we have internally that help us monitoring the job availability and also data availability, which is defined by the jobs that actually write the data. This is needed because, as Nitish has mentioned, we have sensitive data where each teams or different studios, they might have different SLA requirements. So we want to have an overview of what jobs and data sets that have meet or missed SLAs. And this can be used by different teams as well. So we have a process to periodically collect the job status and push the data to our data warehouse. And then we also have another process to collect the data metadata, for example, the user-defined SLAs, the output tables, etc., and then push that to our data warehouse. And this process is actually using the GitLab CI/CD pipelines, where we enforce the metadata in the CI test, and then collecting the metadata information upon each job deployment. And then the data is aggregated and served to our monitoring dashboard. And now that we have go through the different objectives we have for schedule and the servers at EA, next let's take a look at the over architecture and integration. And Nitish will next go over that.
All right. Thank you, Xiaoqin. So this is. I just want to give an overall picture of the architecture integration in conclusion, so that you get a high level picture of how it looks like. So this is the overall architecture, platform level architecture of how we have deployed Airflow. It's deployed on Kubernetes, on EKS actually. We have a very well defined deployment pipeline. So if you want to scale up the cluster, scale down the clusters, all that is managed through GitLab. So whenever you make a change, the pipeline is kicked off, and we have a very well defined deployment rolling upgrade for each of the pods there. So we decided on sticking with Celery Executor because we have a lot of jobs usually which talk to external systems. So they usually shoot a query or shoot a API call and wait until a response is given. Sometimes there is wait operations. So uh, we were okay with really light workers, but again we wanted the ability to scale up those workers when as and when required. So Celery seemed like a good option because we have lightweight workers which are which don't impact our resources as much but allow us to scale horizontally accordingly. We are using Redis as a message broker and for transport. We also have a PostgreSQL as a backend. As Preethi mentioned, we have proxy-based authentication. We have a internal SSO system within EA where and then all our proxy-based authentication uses that to ensure that we have the correct tokens and the right person access the right multi-tenant UI and stuff like that. Um, and we also obviously we have the central plugin system which interfaces with the multiple Presto clusters, and as Preeti mentioned, we have multiple DAG repositories which sync with the Airflow pods. So this is the overall infrastructure which you can see here. It's a pretty simple idea. In the future, we would try to make this on demand so that you can spin up your own version of this cluster as in when you see fit. So, how does a team onboard to Airflow as a service, Shield as a service? We have an internal system where they request the access. We provision their GitLab, provision the ACLs required, and as a result, they get multi-tenancy in a shared cluster, monitoring and alerts, obviously, and an easy way to manage and deploy their jobs, and easily develop their jobs. And so this encompasses what we mean by shared as a service. Obviously, in the future, we are you know thinking of evolving this process to strike the right balance, allow teams to create on-demand workers and isolate workloads even more. Also, ad hoc query scheduling mechanisms, if possible. So we see a lot more use to Airflow in the future. So that concludes our talk. Thank you so much for coming, and we are now open to questions.
Great. Thank you very much. Just a reminder, people, if you have questions, you can either use the Ask the Question section in Crowdcast, or you can drop them into the attendees channel in the Airflow Slack, and then I'll forward them on. So I guess let's start with which one? There we go. So you kind of multi-tenancy, and you're using RBAC role-based access control with your EA's SSO. Do you have anything that sets up group membership from your SSO, or is that still done manually?
Uh,
Preeti, yeah, go ahead.
yeah. Thank you, Nitish. Yes, I can answer that. So basically, we have a reverse proxy in between. So having a reverse proxy and also a custom Airflow security model. So we basically take the user information from reverse proxy, and if say this is a new team, we that particular role would be brand new. In such a case, the custom security plugin will note that, and it will automatically go ahead and create that particular role within the Airflow ecosystem. So we do not rely on the CLI or to on the UI to basically go and create a new entry for everything. Same goes for users. We do not manually onboard them in via the UI or the CLI. Or whenever there is a new user and they have the appropriate permissions within their OAuth cookie, they can pretty much use log into F. Yeah. And an entry is created within the users table. Yes.
Right. That makes sense. So you're using a custom Flask
Yes.
app builder security manager. Makes sense.
Yes.
Okay. So multi-tenancy. Do you have any need or protections in place to protect against malicious code from one team affecting another, or is that not something you have to worry about?
So yeah, I've thought about it. So one of the things we were looking at was looking at the executor code base itself, especially the celery executor code base, and thinking of maybe ways of controlling executions. And if we see, access control plugins, it's supposed to not be executed. Um, but we also have malicious code. We ensure that malicious code is not executed within our Presto platforms, and stuff like that. And because we have access control within those plugins, so not anyone can run any plugin within Airflow. So for example, if I have a certain plugin which I'm running, but it's slightly, I can't access FIFA's plugins when I'm running. So the chances of malicious code is less, but yes, we are still looking at how we can isolate that even more.
Sure.
Yeah, and to add to what Nitish said, we currently have a GitLab link. So basically, in the GitLab link, for example, there are certain teams that are prohibited from using the bash operator. So automatically, you wouldn't be able to merge your code if you were using the bash operator. So we do have ways in which we can stop certain malicious users or certain operations that we wouldn't want to support for certain things.
Great. Thank you very much. Um, you mentioned you were using Uzi a while ago. How did you migrate from Uzi to Airflow? Was it automated? Was it manual? Was it difficult? Was it? Yeah.
Uh, I mean, it's a long process. I mean, we're still process migrating. We're thinking of the next version of ETL's job so that the Uzi jobs still remain as it is, and we deprecate the older jobs as and when they come, as and when we see fit. So it's hard to actually migrate all of those jobs. We migrate. That's a manual process. Again, Preethi can testify. Preethi and
Yeah.
Xiaoqin can testify to that. It's a slow
Yeah.
process.
Yeah, and also I think when Nitish mentioned slow process, the reason being Uzi was integrated with our Hadoop and Hive ecosystem, while Airflow is integrated with our Presto ecosystem. So most of the cost comes down to rewriting the Hive queries to Presto, so and C-SQL for that matter. So, in other words, that is where I would say, from a data engineering perspective, the most time is spent. When it just comes to if say you already had a Presto query that you would want to migrate to Airflow, as Nitish mentioned, all the boiler stuff code is removed. So you just have to provide your .q file, and then you're good to go within Airflow. So yeah, most of the cost is because of Hive versus Presto, and not really Uzi versus Airflow.
Perfect. That makes sense. You mentioned you have a lot of plugins. I guess many of those are kind of very specific to EA and your internal data warehouse and data processing. But have you considered open sourcing any of those plugins?
So,
Uh,
uh, yeah, let me take it first. So, most of the plugins are talking to internal ES systems in general. I think none of them factor into the open source use case as far as I see. But yes, definitely, we always have a open source. Contribution to open source is always on the agenda. So when we do look at a plugin and we think, okay, this can be generalized for an external use case, we do think about it. But because we are comparatively in the nascent stages of it. We haven't seen a plugin which is not talking to a internal system and which is generic enough. But yes, that is always on the agenda.
Yeah, and from the RPAC model, definitely we are, especially when it comes to the custom security plugin model, we have a thread where we want to at least provide that as an example to the Airflow community. Yes.
Perfect. There's a couple of questions around your kind of monitoring. What GUI did you use, and which tools and components are you using to do the kind of the monitoring?
So we have a Grafana dashboard, which is usually spun up uh, for a team. So that is Grafana is our major monitoring dashboard as such. For slightly less like lightweight and more aggregated monitoring, we usually have Superset, which and also we in before we used to have custom Angular JS application, which you would have high charts and stuff like that. But right now we are moving towards Superset and Grafana as our go-to tool for monitoring.
Yeah. And we also collect the Prometheus metrics. Yeah.
Yeah. Prometheus is our again go-to way of collecting metrics, and as Xiaoqin mentioned, that we have other slightly, other scripts to just collect static metadata and also show that in our superset graphs and also the custom Lighthouse, uh, Angular JS app which we have.
I think we've got time for one or two more questions. How do you handle updates of an Airflow version? If this is kind of a shared multi-use cluster, how often do you upgrade, and what checks do you do to make sure it works? If
All
you've had
right.
to do it yet.
Yeah. So we had to do that a couple of times. So we have a CI environment which is exact replica, except the worker count and some of the resources are low. But we have a CI environment which is exact same as the production environment. So we have a Docker image which we uh, update the version and push it to the CI environment on EKS actually, and then we run a bunch of tests. We run some load tests. We run all the plugins on it just to check if there are any compatibility issues. Once we are satisfied that the configurations are fine and everything is working and everything is kosher, then we schedule an update for the production version. We intimate all the studios and then go ahead and do it in a 30-minute window. So that's how we do it.
Gotcha. Okay, and I think final question. You are using the Celery executor. Did you consider Kubernetes? And do you think that would give you better scalability?
Yes. So Kubernetes, we were looking at it, and one of the things is spinning up a pod and then spinning down. Like that was one of the things we were looking at. And initially, we stuck with Celery because it was just easy to scale up. And Kubernetes executor and the pod operator, both of them are in our plans for the future. Basically, we are looking at implementing it as and when we see, especially with the multi-cluster model, which we are looking at. Currently, we're sticking to Celery and then just scaling up the workers accordingly. But yes, we did look into it, and that is one of the things which we want to implement, but we just haven't gotten around to doing it yet.
Great, thank you very much. Just looking at time. Do you have any kind of scaling, automatic scaling, I should say, on your cluster?
Uh,
No, on the pods on your cluster, not on the cluster itself. Sorry.
you mean on the web pods or the worker pods, or?
The worker pods specifically was the question, but the web would be interesting as well.
Right. So interestingly, that was exactly the thing I was trying to do using horizontal pod autoscaler, which is the exact thing which I started looking at last week. So we are in the midst of it, but as of now, we don't. We update the config on GitLab, and then it is updated, scaled up through a pipeline. But again, yes, we are in process of doing it.
Gotcha.
Yeah.
Okay, I think that is all we have time for. So thank you very much, Nitish, Preethi, and Xiaoqin. And thank you everyone for joining us. Tomorrow, starting at the same time, so 3 hours ago, we have the second session hosted by the New York City Airflow Meetup. Remember, the recordings will be available. As soon as the session's over, you can view the recording in Crowdcast, and they'll be available on YouTube after our lovely production team has had a chance to edit some of them. Also, please check out our virtual swag bag. If you go to airflowsummit.org, and then in the menu or at the top, there is swag, some books, some discount on books, and also the chance to win a rather lovely pair of Bose noise cancelling headphones. So please all do check that out. And thank you very much to our speakers, and thank you everyone for attending. And we will see you hosted by New York City Airflow Meetup tomorrow. Thank you very much, everyone. Goodbye.